Bismillahirrahmanirrahim. Thank you for giving me this opportunity. My name is Engr.Mutahir and I am currently enrolled at University of Engineering and Technology, Peshawar, as a structural engineering student. Today I am going to present my research topic, which is dynamic response and strength evolution of a mobile heritage structure. The presentation online is comprising of the introduction section, literature review, problem statement, objectives, methodology, and results, and then finally conclusion. Mughal heritage structures are the integral part of Pakistan, which include famous structures such as Lahore Fort, Golgatri, Muhammad Khan Mosque, which is located in Peshawar, and many other historical and cultural structures. These heritage structures are basically the identity of its people, and the preservation of originality and culture is considered a social value. From the past 2 to 3 decades, due to uncontrollable urbanization and land uses, the growing density of people, these heritage structures are now deteriorating with the passage of time. Similarly, in this picture, we can see that this is the picture of Gorgatri in Peshawar, which the structure is under, which is damaged right now and under restoration. In this picture, the discoloration occurred on the outer surface, which is due to the environmental impacts. So the structure, these two images show that it can be damaged from the material as well as the environmental impacts. So in this image, we can see that there is a lack of coordination between two walls, and therefore it will not have enough resistance in case of seismic activity. We can see the thickness, which is usually very high as compared to the modern structures right now. So if I summarize the introduction section, there will be 9 points. So the main failures to these heritage structures occur due to the strength loss of old materials, because the materials were capable of sustaining only compression loading, but with the passage of time, due to aging problems, they lost shear and tensile strength. Similarly, the depletion of the load-bearing elements and the heaviness of the structures due to earthquake, it can damage, and the lack of coordination between ceiling to walls and wall to wall, poor workmanship in these heritage structures, non-homogeneity between masonry units, environmental impacts, aging problems, irregularities, and poor performance in seismic activity leads to these failures. The methodology section consists of 3 parts. In stage 1, the traditional bricks were provided by the archaeology department of Peshawar, and then mortar cubes were prepared. Brick powder was made from the brick units and lime mortar. Similarly, in stage 2, testing was done on mortar cubes, bricks, and sieve analysis was performed, and the consistency test was performed on the mortar to give a suitable water to cement ratio. In stage 3, fabrication of walls were made and polish and test was performed. The result sections, the influence behavior of masonry walls subjected to horizontal and vertical forces has been investigated in this experimental work. As indicated by these experiments, the influence response of masonry walls depends upon their failure mechanisms, the shear, sliding failure, diagonal shear, failure, rocking, and hybrid. So all of these mechanisms were studied in this research study. The vertical load were varied from 98 kilonewtons up to 96 kilonewtons to study the failure mechanisms which are influenced by the vertical loads. The wallet number 1 at 4 mm displacement cycle horizontal cracks are developed. Similarly, as well as the plunger mechanism was initiated in the form of rocking mode, and the specimen takes a higher displacement limit up to 14, but at 16 mm displacement cycle, it develops horizontal diagonal cracks and subvertical cracks. If I go through the historic response of the break quality, it was linear up to 1 mm displacement cycle. However, the peak lateral resistance of specimen keep on increasing with the increase in the displacement cycle. This can be attributed to the increase in shear strength. So this specimen will have a low vertical load and it behaves in flexure compression failure, which have lower stiffness and as well as lower displacement capacity. Failure mechanism of wallet 2 is totally different from the wallet 1. You can see that at 3 mm displacement cycle, minor cracks were developed and rocking mode was initiated, and at 10 mm displacement cycle, diagonal cracks are developed, as we can see in this image. If we study the historic response, this specimen sustained higher peak resistance as compared to the wallet 1 due to increase in the pre-compression level, as well as it increases the elastic stiffness and the displacement ductility. Similarly, wallet number 3 behaved differently from other specimens because due to increase in pre-compression level at 3 mm displacement cycle, it developed diagonal cracks, which can be seen in this image. The hysteric response was quite different because it was facing diagonal shear failure. It has very low stiffness and low displacement capacity because of increasing the pre-compression levels. However, with the increase in displacement, there was increase in the lateral capacity of the brick wallet. It was linear up to 1 mm displacement cycle. This is specimen number 4. Specimen number 4 have a diagonal crack appeared on the surface of the brick wallet at 6 mm, and it behaves quite differently from the other wallets. With the increase in displacement, there was increase in the lateral load capacity of the brick wallet. However, the response was linear up to 1.5 displacement cycle. It has a higher elastic stiffness and but lower displacement capacity because it was filled at 6 mm. If I summarize my whole results, I can make relations between them, and this is the vertical load which were valued in this research, and the peak lateral resistance is given. If we compare these two together, we can see that due to increase in vertical load, pre-compression loading, peak lateral resistance was increased, as we can see in this image. But peak lateral resistance also depends upon the failure mechanism. If we see this number 3, which was failed in pure diagonal shear failure, so it has a lesser peak lateral resistance and lower displacement ductility factor, and it is found from it can be seen in the literature as well. It has also a lower elastic stiffness due to diagonal shear failure. Similarly, if we compare these two columns together, we can see that flexure control specimen have a higher displacement ductility as compared to shear. So some walls simple number 3 behave in pure diagonal tension, and while other behave in a hybrid mechanism, starting from flexure and then shear initiated. So And if we compare these two together, elastic stiffness is a vertical load. So due to increase in the pre-compression loading, there is increase in elastic stiffness, which could be attributed to the strength of the masonry. The conclusion section has a result shows that the pre-compression has a significant impact on the failure mechanism of the brick wallets, as we have seen in the wallet's behavior. Peak resistance is governed by the formation and development of diagonal cracks. In case of shear failure, the response is quite rapid. Stiffness is degraded as well as the displacement capacity is reduced as compared to the flexure controlled sections. This research study shows that the failures in the heritage structure can be addressed with a non-invasive approach such as grouting for the retrofitting of these damaged brick wallets.